All right, guys. So the next thing we're going to graph is the cosine function. Notice in the top right, I just made a quick little chart, a little table with the values of cosine going from 0 all the way to, positive 360 all the way to negative 360. So I have them all written out. So I don't have to keep flipping back to the other table. Okay. Remember that the negative 90, negative 180, negative 270, negative 360 is from us going clockwise around the coordinate plane. Okay, and that's where we get those values from. Also, you can just plug them right into GeoGebra. You could literally put in cosine of negative 180 and it'll give you negative 1. Cosine negative 360 will give you positive 1. Okay. You're okay. Here we go. Oh, okay. Sorry, my son just got his finger stuck in a car. Okay. By the way, not to go off topic, but I have been trying to record this same lesson 10 times, and every time I have gotten interrupted either by a baby screaming, the bell ringing, the phone ringing, or something else. So hopefully this is the last time I can record this. Now, all right, let's graph y equals the cosine of x. All right, so 0 when we have x is 0, cosine is 1. Okay, so the degrees or the radians are going to be our x values, and even though this is cosine and we know cosine is x and sine is y, this is just a little bit different. It's not like the regular coordinate plane. Here the cosine value is our y value. At pi over 2, remember this is 90. I'm just going to write these in real quick so that we know what the degree values are. The more you do this, the more you're going to remember, and you're not going to have to fill in the degrees. Okay, but I do find it helpful in the beginning. Okay, so for 90 degrees, cosine is 0. For 180, cosine is negative 1. For 270, cosine is 0. And for 360, we're back up at positive 1. Now for the negative side, cosine of negative 90 degrees, excuse me, is 0. Cosine of negative 180 is negative 1. Cosine of 270 is 0. Negative 270 is 0. And cosine of negative 360 is positive 1. Okay, and we're going to connect these again, forming a curve. Okay, we're going to form a curve. Not a V shape. Remember, V shape is really only for absolute value. Okay, and that is what your cosine curve looks like. Now let's take a look. The next slide just gives you the instructions for doing this on your graphing calculator. Okay, the first 3 steps, this is really for the graphing calculator, the old school TI graphing calculator. And then you have the steps there for GeoGebra, okay, because you can literally put this right into GeoGebra and to see the graph. Okay, this is the graph, picture of the graph that we did, the sine function. Okay, this is your cosine function, cosine graph. That's the one that we just completed. Okay. All right, now let's take a look. What we want to do is graph y equals 2 sine of x. Okay, y equals 2 sine of x. So let's first label the x and y axes. All right, we can make this 1, 2, negative 1, negative 2. Let's make this 90, 180, 270, 360, positive 90. Okay, again, which is the same as pi over 2, pi, 3 pi over 2, 2 pi. Okay, and in the other direction we have negative 90, negative 180, negative 270, negative 360. Okay, so what we can do is make a chart. X, Y. Okay, I'm going to put the... Alright, so pi over 2. Pi. 3 pi over 2. 2 pi. Alright, and what we can do is literally just plug this right into GeoGebra. We're going to plug in y equals 2 sine of x. Let me see if I can split screen this. I should be able to. Okay, so type in 2 sine x. Okay. Take a look at what we got here. Okay. So, if you just tap them here, you see what we're getting. We're getting these crazy values, right? But we know what the x value is, and the x value is pi over 2. So the y value, when x is x over 2, the y value is 2. Okay. At pi, this is going to be pi, see 3.14. At pi, it's going to be 0. At 3 pi over 2, it's going to be negative 2. And at 2 pi, it's going to be 0. Okay? Notice what's happening here. So let's just plot the positive values first. Let's plot the positive values first. Here we have, okay, we know that sine is, at 0, it's 0. Okay, we said at 90, it is 2. Pi, it's back down to 0. 3 pi over 2 is negative 2. And 360 back at 0. Okay. Now going off of that, we can pretty much figure out on our own what the negatives are going to be, or simply scroll to the left of your graph. All right, when it's negative pi, it's going to be negative 2. 0 is going to be, I'm sorry, not 0. Negative 180 is going to be 0. Okay, there's negative 180. Negative 270, it's going to be positive 2. And 360, we're going to be negative 360 back at 0. And we're going to connect that the same way that we did the first one, again, using curves. Okay, and that's what it should look like. So the question is, how does this compare to y equals the sine of x? Remember, this is like your parent function. Okay, parent function. All right, it's just a simple, 1 times the sine of x. Looking back, how does this one compare to the parent function? All right, well, it just got multiplied. Basically, it just got multiplied by 2. So the y values now are increasing by 2. It's basically like you took each the y values and multiplied it by 2, okay? And everything else just stays the same. Okay. We're going to do the same thing now for y equals 2 times the cosine of x. What do you think is going to happen to the graph of the original parent function, right? How do you think, before we do this, how do you think it's going to compare? Well, it should look the same, with the exception now of, instead of those y values being 1 and -1, they should also be 2 and -2. Okay, so let's plug in cosine 2 times the cosine of x. 2 times the cosine of x. Okay, that's what it should look like there. Let's just graph these. Let's say this is 1 and 2, -1, -2, pi over 2, pi, 3 pi over 2, and 2 pi, and do the same thing in the other direction. -pi over 2, -pi, -3 pi over 2, and then this will be, I don't know why that was left out, -2 pi. Okay, so when x is 0, y is 2. When x is pi over 2, y is 0. When x is pi, y is -2. When x is 3 pi over 2, y is 0. And then last but not least, we have y is equal to 2 at 2 pi. Okay, and again, we're going to go in the same direction, just back the other way. -pi over 2 is going to be here at 0. Negative pi is going to be at -2. -3 pi over 2 is going to be at 0. And -2 pi is going to be at +2. And we're just going to connect those. Okay, and that's what it should look like. All right, so it kind of looks like it just got basically kind of elongated as compared to y equals the cosine of x, okay? Kind of like when we did dilations of not absolute value. Oh yeah, absolute value functions and of quadratics. Remember when we multiplied it by a number, like if we took a quadratic equation like y equals x squared and we multiplied that by 2 to make it 2x squared, then the graph became narrower, okay? And when we multiplied it by, a fraction such as 1/2, what happened? It became wider, okay? What do you think is going to happen here when we go to the next one? Y equals 1/2 sine of x, okay? One half sine of x. All right, same thing's happening here, okay? The same thing happens. Now we are getting not narrower, but we're kind of getting a little bit more compressed, okay, as opposed to a vertical like stretch, okay? So same thing here, okay? When x, for 1/2 sine of x, when x is 0, y is 0. Okay, when we have pi over 2, pi, 3/2 pi, and 2 pi. Okay. This is going to be 1/2. Okay, so now we're only going up to here. All right, pi is going to be 0. 3/2 pi is going to be -1/2, which is here. And 2 pi is going to be 0. Okay, and we're just going to go back in the other direction. When we have negative pi over 2 or negative 90 degrees, we're going to have -1/2. When x is negative pi, it's 0. When x is -3/2 pi over 3/2 pi or -270, it's going to be 1/2. X is 1/2, and then last but not least, at -2 pi or -360, we're back at 0. Just connect them, and you have your graph. Okay. Okay, we got 2 more problems left. Okay, so now we're just doing the same thing with 1/2 cosine of x. Okay, I'm pretty sure you guys can tell me at this point what it's going to look like. Okay, same thing, only it's becoming a little bit less, not as steep. Okay. All right. There we go. So let me just label this real quick. 1/2. One. Okay. And up here we have 2. This is 1. This is 2. Pi over 2. Pi. 3 pi over 2. 2 pi. -2 pi. Okay. When x is 0, y is 1/2. When x is pi over 2, y is 0. When x is pi, we get -1/2. When x is 3 pi over 2, we have 0. And when it's 2 pi, we're back up at 1/2. Okay, in the opposite direction, when it is negative pi over 2 or -90, x is going to be 0. At 180, -180, x is going to be, y is going to be -1/2. At -270, it's going to be 0. And at -360, y is going to be 1/2. Okay, and then just connect those. All right, and there you have it. Any questions so far? If you have any questions, just feel free, like I said, to text, Hangout, get me on Google Hangouts, or email me. Okay, quick little Regents review question. Find the solution set of 2x squared plus 5x minus 3 equals 0. Okay, how would we do that? Now, question is it factorable? Okay, can we use GCF on it? Doesn't look like there's a greatest common factor. So what we want to do is see if it is in fact factorable, or if it's not, we have either quadratic formula or completing the square. Remember, when we have an a value greater than 1, we're going to take the a value and the c value, multiply them together, we get -6. We're looking for factors of -6. that add to positive 5. So factors of negative 6 that add to positive 5. We make a list here. We have negative 2, negative 3, positive 2, positive 3, negative 6. Oh, wait. Sorry, guys. This should be reversed. 1 positive, 1 negative. Okay, negative 6, positive 1, positive 6, negative 1. Do any of those add up to positive 5? We got this one right here. So we're going to rewrite that middle term using those two factors. 2x squared plus 6x minus 1x minus 3 equals 0. Here we're using factor by grouping. Okay, factor by grouping. Okay, box the first two terms, box the last two terms together, find the GCF for both. Okay, what's the GCF of 2x squared plus 6x? That's going to be 2x. So we're going to factor that out. And what's left in the parentheses, we're going to divide both by 2x. And what we get when we do that, we're going to put in the parentheses. So 2x squared divided by 2x is x. 6x divided by 2x is 3. Do the same thing for the next set of parentheses. The GCF is negative 1. Remember, whenever you have a negative sign, you're pulling, the GCF is going to include a negative. And then we're going to divide both by negative 1. And we get x plus 3. Notice we have the same thing in both sets of parentheses. That's what we should have. If we don't, we made a mistake. We got to go back and try to fix it. Okay. At this point, what we're going to do is what we have in both sets of parentheses, remember that that's our overall GCF. We're going to only write it once, and leftovers go into a second set, 2x minus 1, set that equal to 0. Okay, now it's telling us to find the solution set, which means we're not done with, as soon as we're done factoring, we actually have to find the solution set, which means find the value or values of x. So at this point now, we're going to tee off. Okay, take x plus 3, set it equal to 0. Take 2x minus 1 and set it equal to 0. Okay. Subtract 3 from both sides. Over here we get x equals negative 3. And over here we get x equals 1/2. Okay, so remember, you can always check that using GeoGebra as well. Okay, hope you found this video helpful, guys. Again, if you have any questions, you need any help, you know how to reach me. My office hours are from 9 to 10:30 and then 12:30 to 2. Okay, take care, guys, and I'll talk to you later.